Thanks. Hello, welcome. So I'm Eric Klarenbeek. To start with, our studio focuses on experimental research. So what do? We constantly search for these unexplored connections between new technologies, local makers, and local users. So how this results? It results in either these experimental products or even in like applied public space projects. So today I'm going to tell about this mycelium project in which we incorporate growth in our design process. So what we do, we 3D print living mycelium cells and therefore to bind local waste. And this with our goal to create products with a negative footprint. So this all started in Mumbai, India. It was during a research trip with Droog Design, and we worked with the locals in these informal settlements. So, and in these buildings, they were melting these plastics and using them for, and grinding them and exporting them for further application. And it felt pretty comfortable to be with these people and in these fumes of these plastics, as we apply these same plastics for our 3D printers locally and the makers around us. So, and actually also in these kind of small spaces and unventilated, kind of equally. But I also saw the strength of these informal settlements, the density, how all these people work together, and how it has such an effectiveness and efficiency on how these people work together. So we started to search further from what are the plastics applied for 3D printers. So in the Netherlands you have either these oil-based plastics or you have the bioplastics, and they both involve these intense process of fabrication and transportation, as we can only get our resources from either the States or from Asia. And also these bioplastics, they put even more pressure on agriculture and on and involve also GMOs. So we thought, if we can reduce this whole process, would it be possible to grow immediately living cells and leave out all this transportation and fabrication and immediately have an end result, an end product, without this complex system? So everything can be done locally. So we started by cooperating with the University of Wageningen. And we built this mobile lab in one of these public parks by using open source printers. And instead of melting plastics and piling them up layer by layer, we used grounded straw and wood which we could find around us, and grind it and use it as a kind of paste, and the mycelium as a binder. So this brought us in contact with the mushroom research group. And then we started to make all these samples, so variations between straw, new materials, mycelium, to experiment with its density and inner structures. And finally resulted in this process, which can be done all locally. So we harvest local straw, branches, we grind it, and then we inoculate it with this mushroom material. So it grows through the substrate, but just before it gains its strength, so we 3D print it as a paste. And then we leave it to rest for 1 or 2 weeks. And then what happens? You start with this loose powdered straw, the left side, and on the right side, the result after a couple of weeks, bound all together by this living mycelium. And we print this material, so this loose material by paste. And we use open source printers to do this, not only supporting this community, but also enabling us to modify both the hardware and the software for our own needs and bring this development further. So we can also develop printers and define its structure, strength, and etc. So imagine what you can all do with this new technology. And after this is printed, we grow it. So here you see it 1 week later. And then we printed a complete chair. And here is our mushroom grower here in Brabant, and waiting there for a couple of weeks. And then this happened. So full bloom 2 weeks later. Not really necessarily for the material, but for us, it was this magical moment and the poetic reflection of where the material comes from. And also as a proof of concept that we can show that we can actually print this living material and that it will full grow the whole product. And then we have to dry it. So here you see a second, it's a stool, it's called Field Lady. It holds these mushrooms within. And once you dry it, it becomes structural, durable, and also functional. So you can actually sit on this stool. And so if you think from what we can do with it, it can really vary from like products, fashion, till architecture. So the technology is present. We already have it. But what about the makers? And this is a map of 3D hubs. It's a Dutch initiative. It's a website. You can upload your design, search a local maker, and it's already so dense that like within its 1.5 years of existence, we have already makers around our corner which we can reach by bike. So if we embrace these makers and try to convince them of using local materials, and not only they already print with bioplastic mostly, luckily, but convince them to use our local resources, we can abandon this whole chain of waste. And we don't need to import all our goods from abroad, but we can produce everything locally with our local materials. So now we've printed a stool, and secondly, a chair. And we're already cooperating with a Dutch company which is building printers which reach over 2.5 meters high. So imagine that we can think in terms of architecture. Imagine how the cities would look like. So if we would embrace all these makers and all these people around us by convincing them in this new revolution, we can absorb waste and use by producing more, absorbing waste more and more. And not only finding this new balance in producing, but also the waste we produce would also fertilize our environment. So I hope through this process we can refine our natural balance. Thank you.